Good afternoon, everybody, and thank you for the organizer, Future Minerals Forum, for the invitation. So we'll be talking about geochemistry testing to support the mining industry. And as a start, we will just talk about geochemistry overview by what's geochemistry, why geochemistry testing is important, and application of geochemistry. So geochemistry is actually a branch of geological science that deal with the chemistry of the rocks and minerals in various igneous, metamorphic, and sedimentary process and from high to low temperature in various environments. And why geochemistry testing is important is because it provides a background details for a description about the rock origin and evolution. And geochemistry is actually significantly important for geological science, especially for dating rock in various formation and geological process. The application of geochemistry testing. Geochemistry can be applied to exploration for minerals deposit, and it's necessary to understand the fundamental of geochemical prospecting and geochemical dispersion of element depending on the chemical property. The second slide is talking about the main three components for geochemistry testing, and that's sample preparation. Sample preparation is actually designed to produce a representative homogenized subsample from the raw samples. And secondly is the decomposition, and that's digestion. And there is various type of digestion and methodology that, like aquaregia, 4-acid digestion, or fusion if necessary. And analytical instrumentation, and there is various type of analytical instrument that are available in the market depending on the element of interest that require. Example, XRF, XRD, ICBOS, ICBMS, AES, carbon sulfur analyzer. And over here in the slide, there is pictures showing. So, for example, over there at the far right, there is pulverizing machine and crusher machine that's in the sample preparation. There is gold fusion and also 4-acid digestion. And there is the gravimetric gold ICBOS analysis, and that's glass bead application for XRF analysis. The second slide, we'll be talking about the surfaces overview, so a little bit in details. Starting with the sample prep, and that's including the core surfaces and also the hyperspectral. So usually in the sample preparation, when the sample arrive, they're in different types. So we have drill core, half core, rock, chips, or soil and sediment. And usually they go through a main process in sample preparation, and that's drying, crushing, splitting, pulverizing. There is also specific gravity, bulk density. There is a portable inductive analysis, XRF, can be done when once required. There is also core cutting, and there is TerraSpec, and that's core imaging that can be very useful later on to connect it to the data that's actually being processed and reported by geochemistry testing. Secondly, it's the precious metal analysis, and due to the unique property, chemical property for gold, silver, platinum element groups, they actually pose a little bit of a challenge for geochemistry testing. So, because they actually often appear in heterogeneously actually in geological materials. And we actually require a little bit of large charge for analytical to actually give you an accurate and representative count of those precious metal in the sample, overall samples. And we are actually using fire assay or screen fire assay, aquaregia, bulk, cyanide, or leach well. That's a little bit faster using cyanide, sodium cyanide, for to actually recover precious metals. Secondly, there is generative exploration, first pass, and super trace methods. And those is using partial extraction or various super trace ICBMS method. There is also biogeochem, and that's vegetation, usually done in planet, like the leaves or any part of the planet. And you can analyze the minerals actually present in those planets and study the area around it. There is also hydrogeochem, and that's done in the water. And usually in the water stream or the rivers, you can actually directly analyze the water, the minerals actually content in the water. There is isotopes as well. When you have a target exploration and you're trying to define the ore body, the grade and the size, you're actually using one of those is digesting approach. So there is an aquaregia, and aquaregia is usually broadly can dissolve all the sulfide, the oxide, the carbonate minerals, and also retain the mercury there and some of the volatile elements as well. And for acid digestion is actually quantitatively dissolve nearly all the minerals, but not all of them. Sometimes we actually require a stronger digestion approach, and that's using fusion, either lithium borate or sodium peroxide fusion, especially when the rock contain alumina or silica, and that's a little bit, hard with normal digestion approach. And then we have the whole rock, lithogeochem, and carbon and sulfur. So usually in the investigation of geological and the ore form process, it's enhanced and targeted by lithogeochemical, and there is various testing that's used many subsamples that's been done during the geochemical program. That's to actually define the characterization, the full characterization of the rocks type and the trace element that actually associated with it. But it's kind of not stable due to the formation when metamorphism happen. And the carbon and sulfur is actually widely, with the compound, is widely available. It's come with the material, geological materials, and it's available in the ore deposit. And that's actually sometimes it's impacting an issue for the miners, the ore process, and the way how they can actually store the waste of that during mining. So defining the form and the presence of the carbon and sulfur and the compound in their ore help them speed up the ore process and also have a characterization for the waste management there. Over here, this is commonly tested commodity. So the provision analytical testing appropriate for all commercial of minerals commodity that's actually tailored to meet the geologist exploration, the miners, the minerals process engineer, the meteorologist, and those data that extracted are actually utilized for exploration, feasibility, resource planning, minerals control, and concentrated and billion determination, and acid-base count as well, process plant control, and ore characterization and treatment study as well. So commonly there is gold and sulfur, there is copper, zinc, lead, bauxite, iron ore, lithium, uranium and thorium, there is graphite, rare earth, there's cobalt, minerals, sand, and industrial minerals, and other commodity as well. This is just the resource life cycle for the mine. So it's starting with geochemistry testing at the beginning for exploring, and then developing by doing feasibility study, designing, then after that to the mine, actually planning, and then there is a laboratory at the mine site that's actually done geochemistry in daily basis for quality control, to the last step, and that's inspection for trade purposes. So you are welcome to visit our booth if you have any inquiry or questions. Thank you so much for your time. I wish you a lovely day. Thank you.